Good morning. We are here today to introduce 369 SORTWASTE, a groundbreaking standard poised to revolutionize waste management globally. This system isn't just another set of guidelines. It's the world's first mathematically defined color standard for waste sorting. We've harnessed mathematical precision to bring clarity and efficiency to recycling, ensuring that every piece of waste finds its correct destination. Our core equation, x plus y plus z equals 18, underpins a system that is both elegant and profoundly effective. We believe this approach will eliminate confusion, reduce contamination, and significantly improve recycling rates worldwide. This is about sorting smarter, recycling right, and building a better tomorrow for everyone. The current state of global waste management is, frankly, chaotic. We face a pervasive problem: a lack of any unified standard for recycling bin colors. Consider the stark reality. Over 30 different color systems exist worldwide, none of them mathematically consistent. A blue bin in Poland signifies paper, but in Germany it might mean packaging, and in the UK it could be anything. This inconsistency leads to massive errors. An estimated 30% of waste is incorrectly sorted due to unclear labeling and imprecise color definitions. This global color chaos costs billions annually in missorted waste and lost resources. We must address this fundamental flaw in our approach to recycling, and 369 SORTWASTE offers the definitive solution. Our solution to this global chaos is rooted in mathematical precision. 369 SORTWASTE defines every single bin color as a precise mathematical coordinate within the RGB color space. We achieve this by strictly limiting each RGB channel to just three values: 0, 128, or 255. This creates a finite, closed color space of exactly 27 unique combinations, derived from three channels multiplied by three values, that is, 3 to the power of 3. Crucially, 21 of these 27 combinations are assigned to specific waste fractions, leaving 6 as a reserve for future expansion. This means every color has an exact, unambiguous RGB, CMYK, and HEX code, eliminating any close enough approximations. This mathematical rigor ensures that, for the first time, a recycling color standard is universally unambiguous, a stark contrast to the current fragmented landscape. Let's delve deeper into the mathematical elegance of our color space. We've established a system where three distinct values, 0, 128, and 255, are applied across the three primary RGB channels: red, green, and blue. This simple yet powerful constraint yields exactly 27 perfectly distinct colors, a direct result of three values raised to the power of three channels. These 27 combinations are naturally organized into three levels based on the red channel's value: 9 dark or cool colors at or equals 0, 9 mid-tone colors at or equals 128, and 9 warm or bright colors at or equals 255. Our system strategically utilizes 21 of these 27 combinations, representing 77.8% of the available space, while 6 remain as a vital reserve for future expansion. This structured approach ensures both comprehensive coverage and future adaptability, moving us from the theoretical to the practical application of this standard. The first and most fundamental level of our system is x equals 3, designed for the home kitchen. These three bins, using the pure RGB primary colors, are intuitive and cover approximately 80% of daily household waste. First, we have the mix bin, colored a vibrant blue with RGB values of 0, 0, 255. This bin is for all mixed waste, both recyclable and non-recyclable, and it's crucial to note this is not for paper, which has its own distinct color. Next, the BIO bin is a clear lime green RGB 0, 255, 0 for all organic waste like food scraps and bones. Storing it cool helps slow decomposition. Finally, the glass and ceramics bin is a striking red RGB 255, 0, 0, serving as a visual warning for sharp edges. These three primary colors form the most universal and easily recognizable set on Earth, making initial sorting effortless and highly effective. Moving beyond the home, the Y equals 6 plus 1 category introduces 7 additional bins for the waste shelter, completing the household sorting chain. This expansion leverages the CMY primary colors, cyan for paper, magenta for textiles, and yellow for plastic and metal, alongside 4 mathematically derived midtones. These precise color assignments, such as cyan at RGB 0, 255, 255 for paper, eliminate ambiguity and ensure consistent sorting. The inclusion of specific bins for hygienic waste, marked by maroon at RGB 128, 00, and ashen slag, designated gray at RGB 128, 128, 128, addresses often overlooked fractions. This systematic approach ensures that a broader range of materials is properly segregated at the community level. This brings us to a critical new addition, the 21st bin, which addresses a growing challenge in waste management. The 21st bin, dedicated to composite packaging, is not merely an addition. It is a strategic imperative, addressing one of the fastest-growing and most problematic waste streams in Europe. Assigned the mathematically perfect spring green, RGB 0, 255, 128, this color precisely positions composite packaging between organic and paper in our color space. Currently, these materials are often missorted into either paper or plastic and metal bins, leading to contamination and reduced recycling efficiency. By providing a distinct, semantically appropriate color, we eliminate this confusion. This bin is not just mathematically elegant. It is legally and ecologically necessary for effective waste management. Now, let's consider how we mathematically close the entire system with 2 special fractions. The special fractions, plus 10 and plus 11, represented by black and white, provide the mathematical and logical boundaries for our entire color system. Black at RGB 000 is designated for ballast, the non-recyclable residual waste that marks the absolute end of the recycling chain. This corresponds to 100% black in the CMYK model, signifying the absence of all light. Conversely, white at RGB 255, 255, 255 is reserved for liquid waste, such as cooking oils and industrial fluids, representing the absence of pigment and the transparency of liquids. Together, these 2 colors form the absolute boundaries of our defined color space, ensuring that every fraction, from pure black to pure white, has its precise place. With these foundational elements in place, we can now delve into the specialized fractions managed at the waste bank. The Z=9 category, managed at the waste bank or PSCOK, introduces 5 specialist fractions designed for materials requiring dedicated infrastructure and processing. Wood, assigned olive at RGB 128, 128, 0, captures furniture offcuts and branches, reflecting its earthy nature. Metal, now separated, receives teal at RGB 0, 128, 128, a color that visually and phonetically aligns with steel. Similarly, separated plastic is designated light yellow at RGB 255, 255, 128, a lighter derivative of the general plastic bin, ensuring clear distinction. Construction waste, such as rubble and tiles, is assigned azure at RGB 0, 128, 255, a cool mineral blue. Finally, bulky waste, including large appliances and mattresses, is marked navy at RGB 0, 0, 128, a dark, heavy derivative of the mixed blue. These precise color assignments ensure that even the most challenging waste streams are handled with clarity and efficiency. Let's continue with the remaining 4 fractions in the waste bank. Continuing with the Z=9 category, the waste bank addresses 4 final fractions, encompassing hazardous, organic, and gaseous materials, each with a distinct and semantically appropriate color. Tires and rubber are assigned purple RGB 128, 0, 128, a dark, robust color that visually connects to the material's properties. Hazardous waste, including chemicals and medical waste, receives rose RGB 255, 0, 128, the most alarming color in our system, serving as an unmistakable warning. Volatile materials, such as gas cylinders and aerosols, are designated violet RGB 128, 0, 255, reflecting their ethereal and potentially dangerous nature. Finally, green waste, covering garden and plant-based materials, is assigned dark green RGB 0, 128, 0, a deeper derivative of the BIO bin's lime green. These assignments complete the comprehensive framework for specialized waste management, ensuring safety and precision. This full palette of 21 colors represents a complete and expandable standard. We've meticulously designed a complete palette of 21 distinct colors, each serving a critical role in waste segregation. This isn't just an arbitrary selection. It's a carefully curated set derived from the mathematical structure we've established. These 21 colors represent the core of our system, covering all essential waste fractions while maintaining a logical and expandable framework. This comprehensive approach ensures that every type of waste has a clearly defined and universally recognizable destination, moving us closer to a truly circular economy. And this brings us to the underlying mathematical elegance of our system. The true innovation of 369 SORTWASTE lies in its mathematical foundation. A 3 to the power of 3 equals 27 color space. We're not just picking colors. We're systematically defining them within a precise RGB framework where each channel can only be 0, 128, or 255. This rigorous definition eliminates ambiguity, ensuring that a color like blue is always RGB 0, 0, 255, not a subjective shade. We currently utilize 21 of these 27 possible combinations, leaving 6 in reserve for future expansion or specialized waste streams. This mathematical precision is what guarantees global consistency, a stark contrast to the chaotic systems we see today. So, how do we put this elegant structure into practice? Implementing 369 SORTWASTE is a scalable process, designed to integrate seamlessly into existing infrastructure at 3 distinct levels. At level 1, the home or apartment, we introduce the great trinity of 3 bins for mix, BIO, and glass and ceramics, handling approximately 80% of daily household waste. This simple start makes proper segregation accessible to everyone. Level 2 expands to the waste shelter, adding 7 more bins for fractions like paper and textiles, managed by a trained waste sorter. Finally, Level 3, the waste bank or PSCOK, handles 9 specialized fractions, completing the full circular economy loop. This tiered approach ensures that the system is adaptable, efficient, and ultimately effective. But who will be the human element driving this efficiency? The professional waste sorter is the linchpin of the 369 SORTWASTE system, a crucial new profession for the future. This role isn't just about collecting waste. It's about expert management, education, and oversight at the waste shelter and mini-sorting stations. A waste sorter knows all 21 bin colors, can identify every fraction, monitors fill levels, and educates residents on proper segregation. We're talking about a regulated profession with draft legislation already in motion in Poland and a clear path for EU adoption. This creates significant economic opportunity, with an estimated demand for 1 waste sorter per 500 to 1,000 residents. This human element, combined with our precise color system, sets us apart from anything currently in place. Let's look at how we compare. When we compare 369 SORTWASTE to existing systems, the differences are stark and compelling. Our system stands alone with its mathematically precise definition of colors in both RGB and CMYK, a feature entirely absent in current European or local systems. We offer 21 fractions with a built-in reserve, far exceeding the limited scope of most existing solutions. Crucially, 369 SORTWASTE is designed for global scalability across 3 distinct levels, a capability that current systems largely lack. This means full color consistency, eliminating the confusion caused by varying shades and interpretations. We even account for composite packaging, a critical oversight in many current models. This isn't just an improvement, it's a paradigm shift. Our system isn't just innovative, it's also meticulously aligned with existing and upcoming legislation. The 369 SORTWASTE framework anticipates and exceeds current EU waste directives, ensuring future-proof compliance. For instance, the EU's packaging and packaging waste regulation, mandating separate collection of composite packaging by 2030, is already covered by our proposed bin number 21, Spring Green. Similarly, the EU Waste Framework Directive's requirements for separate collection of paper, metal, plastic, and glass are fully integrated into our Y=7 shelter bins. Even the WE Directive for electronics and the batteries regulation find their precise place within our system, with bin number 7 orange for WE and Z7 rose for batteries. This means 369 SORTWASTE is not merely a theoretical proposal. It is a practical, actionable blueprint for immediate and long-term regulatory compliance across Europe and beyond. Achieving global standardization requires a clear, phased approach, and we have meticulously mapped out this journey. Our first step, the national pilot in 2025 to 2026, involves implementing 369 SORTWASTE in 3 to 5 Polish cities. Here, we will train the inaugural cohort of certified waste sorters and gather crucial data on sorting accuracy and contamination rates. Following this success, European adoption from 2027 to 2029 will see us submit the system to CEN for EN standard recognition, aligning perfectly with the PPWR 2024 implementation timeline. We will also publish open-source design files, empowering manufacturers to produce compliant bins. Finally, by 2030 and beyond, we aim for global ISO standard status, submitting to ISO TC 297, translating the system into all UN official languages, and deploying it in parallel with UN Sustainable Development Goal 12, fostering responsible consumption and production worldwide. This is a deliberate, strategic path to universal adoption. Now, let's address a critical point of clarification. Why not 21 bins? The answer lies in the system's inherent mathematical integrity. Adding a 21st bin for composite packaging, such as Tetra Pak, would actually break the elegant logic of 369 SORTWASTE. Composite materials are already effectively handled within our yellow Plastic Plus metal bin, which is designed for multi-material recovery. The truth is, 20 bins provide a complete and functionally exhaustive solution for all municipal and specialist waste streams. This preserves the intended mathematical structure of x equals 3, y equals 6, plus 10 and plus 11, and z equals 9, avoiding any redundancy or unnecessary complexity. We are not just creating a system, we are perfecting one, ensuring every element serves a precise, non-redundant purpose. The number 20 holds a profound significance, extending beyond mere practicality into the realm of mathematical perfection. In 2010, mathematicians proved that every possible configuration of a Rubik's Cube can be solved in 20 moves or fewer. This absolute limit of complexity is famously known as God's number. We find a powerful parallel in 369 SORTWASTE. Just as 20 moves solve any Rubik's Cube, exactly 20 bins can correctly sort every possible piece of municipal and specialist waste. This isn't an arbitrary number. It is the ultimate mathematically proven limit of waste resolution. Our system is minimal, complete, and perfect, offering an elegant solution to a complex global challenge. It is the God's number for waste sorting. We invite you to join this transformative movement. The 369 SORTWASTE standard is not proprietary. It is open, free, and ready for immediate implementation. We believe in collective action to build a cleaner, smarter world through mathematical precision in recycling. Visit our website at 369sortwaste.pl. Email us at info@369sortwaste.pl or call us directly. Let's collaborate to establish this global standard. Remember our guiding principle: sort smart, recycle right, build a better tomorrow. Together, we can redefine the future of waste management.